So the input to the Brown clustering algorithm is a corpus of words, or rather sentences. This could potentially be quite large. We might use a few million or a few tens of millions or even a few hundreds of millions of sentences. And as I said, one advantage of the Brown method is that it doesn't require annotated data, so you can just use raw unannotated text that you might find on the web or in newswire data or various other sources. It can produce two types of output. The first is a partition of words into word clusters, and the second is actually a generalization of the first, which is a hierarchical clustering of words. So let me actually give you some examples of these two types of outputs. So firstly, here are some example clusters. This is actually from the original paper by Brown and colleagues from 1992. And so again, remember, the input to this algorithm is unlabeled text. What they've shown here is some different clusters that their algorithm recovered. So this is basically a partition of the words in the vocabulary into clusters in such a way that similar words appear in similar clusters. And these are really rather striking. So the first one, if we look here, has this. Let me give a very simple hierarchy. So say I have just 6 words in my vocabulary, say apple, pear, boy, girl, and maybe said and reported. So we might in that case have a hierarchical clustering which looks like this. So if I take any node in this tree that I've drawn here, I end up with a cluster of words. So this node here, for example, corresponds to the 2 words boy and girl. This node here corresponds to the 2 words apple and pear. This node here corresponds to the 2 words said and reported. I can go higher in the tree, so this node here would correspond to a cluster with 4 words, apple, pear, boy and girl. And finally, the top node in the entire tree is just the entire vocabulary, so this is the least interesting clustering you can think of. But we can see here that we have some kind of hierarchical clustering, which reflects the fact that boy and girl are very similar, as are apple and pear. But in some sense, these 4 words are more similar because they're all nouns than these 2 words, which are verbs. And so a hierarchical representation allows clustering with different levels of granularity. Now, it'll be useful to 1 is actually all 4 words, apple, pear to girl, and 0 is just said and reported. So in any case, it's going to be useful to think of a representation of these hierarchical clusterings as bit strings, as I've shown you here. This is an actual example of a hierarchical representation of this type derived using Brown clusters, and this is from a paper by Scott Miller and others from a conference called NACL in 2004. And we'll look more closely at this paper later in this lecture, where they use these kind of clusters within the context of named entity recognition. But let's take a look at these. Again, you can see that the Brown algorithm has been really remarkably effective in deriving useful hierarchical representations. These representations were derived from a few tens of millions of words, I think, of newswire text. So if we see here, all of these words here have some bit string, which I think is common right the way up here. So the first several bits are the same, so they're deeply nested in some hierarchical tree with the same path down to that node. And again, we have words like lawyer, newspaperman, stewardess, toxicologist. These are clearly people in general. Of course, occasionally there are errors. Here's one. The word slang for some reason is in there. But in general, these representations look pretty good. Similarly, these are company names. So again, these share some pretty long bit string right the way down here, so they're pretty deep in this hierarchy. And finally, these are first names. Okay, and again, these share some pretty deep bit string. Now you can imagine, if you think of the named entity recognition problem, for example, you can imagine how useful these representations can be. Because for infrequent or rare words, or words which were never seen in training data, knowing that a word like consuelo appears in this class of first names can be extremely useful information if we're trying to build a named entity detector.